Welcome. Today we're going to talk about charge and current. The questions of the day are, what is current? And how are electrons, coulombs, and amperes related? Let's start by talking about charges. Examples of elementary charges are protons and electrons, and they cause one of the four fundamental forces of physics. An electron has negative 1.6 times 10 to the negative 19th coulombs of charge. And current is created by the movement of charges. So as these positive charges move to the right, they create a positive current. Similarly, we could think about negative charges or electrons moving to the left, and that would create a positive current in the opposite direction. Either way is valid to think about charges moving and creating current, but I like to think about positive charges moving in the same direction as positive current because I find it easier. So electric current is the rate at which charges pass through a cross section, as shown in this picture below. So positive charges flowing to the right through this cross section, the rate at which that happens. So for a constant charge flow, that would just be then the total number of charges per the length of time. The units for current are amperes, and they're actually named after André-Marie Ampère, who was a French physicist back in the late 1700s and early 1800s, and he's one of the founding fathers of electromagnetism. We usually call them amps for short. It's abbreviated with a capital A, this unit. And 1 amp is equal to 1 coulomb per second. And these dimensional analysis makes sense on this because we're talking about charges, which have units of coulombs, and the rate at which they're flowing through that cross section, so per second. And 1 amp is a large amount of current because there are billions and billions of charges in 1 coulomb. So therefore, oftentimes in class, we will see milliamps as our units. And when you're checking your math, you should also check to make sure that you don't have an answer like kiloamps. If you had something like kiloamps, there was probably a mistake in your math, and we won't ever deal with kiloamps because that would kill you in the lab. There's also different ways of labeling current, positive or negative directions. So here's a arrow in this direction, 5 amps of current. Similarly, we could draw an arrow in the other direction and call this negative 5 amps of current. This is important because you may not know which way current is flowing in your circuit. You may draw an arrow and then make a calculation and realize you ended up with negative current. And that's okay. You can just change the direction of your arrow in the end and make it positive, or just understand that a negative current is just current flowing in the opposite direction. So what happens if my charge flow rate isn't a constant? So here are some examples of currents that vary in time. So notice when it's not varying in time, we use a capital I. And when the current is varying in time, we use a little I. That is a standard we will use throughout this course. So the first animation I created here shows this sinusoidally varying current. So we see the charges are flowing back and forth across that cross section. And that is creating the sinusoidally varying current. Similarly, I have drawn a decaying current here. So you'll see that the charges are actually slowing down as they pass through that cross section. So that's making the current be less and less over time. We can also talk about cumulative charge. So as these charges flow to the right here and pass through the cross section, we can add up all the charges that pass through that cross section, and that's called the cumulative charge. And if we have a constant flow of charge, that's just the current multiplied by the length of time. But what if we have a more complicated current? So in this case, our current is decreasing over time. I can add up the current at each moment in time to get the sum of all the current over time and figure out the cumulative charge. So I just hashed this whole area under the curve, the area under the current curve. That's actually called an integral. And that integral gives us then what the cumulative charge is. And during this semester, you should be learning calculus, and you will eventually learn how to calculate the area under that curve. But for now, it's okay to just conceptually understand how charge and current are related. And finally, this is all important because our devices are charge neutral. That means charge is not accumulating in our devices. So when a charge flows in here, a charge must be flowing out here. And that's true for all of these devices we talk about in class, whether it's a resistor or a voltage source or a capacitor, which we'll talk about later in term. All of these, whatever current is flowing in is equal to the current flowing out. And if that weren't true, if we had charges building up in our device, then you could get shocked when you touch it, which would not be good. So that is all for today, and we will see you in class.